Good morning, everybody. We are no longer filming in Mr. Doran's messy garage. Today we're in Mr. Doran's messy kitchen. And if you tell Mrs. Doran that I said that, or if you even let her know that I'm filming in here, she will end me. So let's just keep that between us. Okay? So I got my dogs running around, got my ferrets running around. My cats are put up downstairs, so they won't be bogging us. But who knows? My other critters might make an appearance. In fact, there's my dog right now. Hi, Ginger. Okay. Let's get back to where we were, shall we? So today, you got Mrs. Jacobs with you. She's a wonderful teacher. Some of you may know her. Some of you may not. And that's okay. But I trust her to get everything done. Anything, if you have any questions, something that I confused you on, she can get you set straight. Okay? Trust me. She's the bee's knees. All right, here we go. Let's take a look at, see, this touchpad on this computer is just going wonky on me. Super sensitive. Here's today's assignment. This is the second page. See, this is what we worked on last week on Wednesday. It was supposed to be what we worked on, but for some reason the pages didn't get passed out. So I got a bunch of blank ones on my desk. Yeah. So let's go ahead and we'll do page 2. All right. We're going to multiply fractions and express the answer in simplest forms. We're going to reduce them as we're going through it. Now these down here, I want you to multiply first and then simplify. Simplify first and then multiply. See if we get the same answer. But we'll get to that when we get to that. So just up here, multiply 1/3 and 12/13. 1/3. That's Ginger. 1/3 times 12/13. All right, so as far as reducing goes, we know that 1 won't reduce down, so these two numbers have to stay where they are. Is there a number that goes at about 3 and 12? Let's start by saying, does 3 go into 12? Because we know 3 will go into itself. Does 3 go into 12? Check your timetable charts. Go over to 3. Go down to 3, 6, 9, 12. Yes, it does. It goes 4 times. Awesome. So that 3 will cancel out and become a 1 because 3 goes into 3 one time. 3 goes into 12, we just said, 4 times. And we multiply that straight across. 1 times 4 is 4. And 1 times 13, 13. Yeah. I'm trying to be tricky on this next one. What is 3/7 of 4/7? So they're saying 3/7 times 4/7. Can we reduce 7 into 7? That's what they want you to think, right? We got to go diagonal. There is no way to, those won't shrink down. We can't reduce that way. They're trying to be tricky. Don't let them get you. There's no way to reduce that. We just have to multiply it straight across. What's 3 times 4? We just did it right here. 12. What's 7 times 7? Use your chart. It's going to be one of the pink numbers going down that diagonal box. I guess for you guys it would look like that. Yeah. Somebody said it. Was it you, Brennan? Not you, Ginger. Sorry. 49. Awesome. 5/6 times 3/10. Sometimes you can reduce this way and you can reduce this way. And sometimes I don't tell you what the answer is because I want you to figure it out. This is one of those times. It says 1/6 times 3/5. Well, 1 won't reduce, right? 1's as low as it goes, so we can't reduce these. Is there a number that goes into both 3 and 6? Start with 3. Does 3, we know 3 goes into itself one time. Does 3 go into 6? I'm not saying. That's for you guys to figure out. Put the answer right there. Now this one, we got 3 different fractions we're multiplying. So I'm going to have some pity on you. We're going to find the product, that's the answer when you multiply, of 2/5 times 3/5 times 4/5. Well, 5 goes into 5. We can reduce those down, right? Wrong. Remember, they tried to do that to us over here, and we didn't let it work. They're trying to trick us because we got to multiply. Oh, sorry. If we're going to reduce, it's got to be from top to bottom, diagonally. But 2 doesn't go into 5, and 3 doesn't go into 5, and 4 doesn't go into 5. So none of these will reduce down. That's a crying shame, but they just don't. So we have to do 2 times 3. What's that get us? Gabe, come on. Gabe, 2 times 3. Yes, very good. 6. And then 6 times 4. Mason, I'm counting on you for this one. 6 times 4. Check your chart. Yes, very good. 24. Now that's the one where it gets a little sticky. You can still do this on your chart if you use the uppy downy side. Where's the camera? Here it is. The uppy downy side. You can get the 5 times 5 is 25 times 5. Check that one out. Go all the way down till you find 25 on your chart. And count over 1, 2, 3, 4, 5 spots. You get 25, 50, 75, 100, 125. Good job. Now, will these reduce into each other? Sadly, no, they won't. But we got the problem solved. All right. So down here, you guys might want a calculator for these. There's a case full of calculators on a counter, or you can use the calculator on your phone. Okay? I'm okay with that. But for these first ones, we're going to multiply first. Go straight across. And then we have to simplify it. We have 5 times 4. We have 5, 10, 15, 20. And then 9 times 5. 5, 10, 15, 20, 25, 30, 35, 40, 45. All right, I'm going to find my factors. And they're 1 times 20, 2 times 10, 4 times 5. 1 times 45, 3 times 15, and 5 times 9. So the biggest factor we have there is 5. So this will reduce into 4 ninths. Then we come over here. We see that 4 won't reduce with 9. That just doesn't work. But 5 and 5, the same number, they're going to cancel each other out. 1 times 4 is 4. Sorry, guys, it's been a long day. 9 times 1 is 9, 4 ninths. Do we get the same answer when we reduced it? Yes, we did. Now, just which one's easier? Some people like doing it this way, and some people prefer to do it this way. I like doing it this way myself because I'm never sure if I'm reducing something down all the way when I do it this way. This way, I know that I've got it with smaller numbers, and I don't have to have like big times tables going in my head. But either way, with this one, multiply straight across 2 times 5 and 7 times 6. Now, you guys can do this one. I'm not doing this one with you. I'm setting it up. Then whatever you get, you've got to do little T-charts over here on the side and see what all goes into it, okay? Will 5 and 7 reduce into each other? No, they won't, but 2 and 6 will. So use that hint. And then, do you get the same answers after you reduce it all down? Yes or no? Nine times 2 over 10 times 3. And then you can reduce that down. After you run your T-charts and figure out what the greatest common factor is. Will 2 go into 10? It will. How about 9 and 3? Well, 9 won't go into 3 because 9 is bigger than 3. But will 3 go into 9? Check it out. And then tell me what answer you came up with. Now, this bottom one here has got 3 different numbers. Yeah, I'll work that one with you. So that's a bit much. This first, we just multiply straight across. 1 times 2. Well, 1 times anything is still that number, so it's 2. And then 2 times 3 gives us 6. We can do these in any order we want to, since it's all just multiplication. I'm going to take my 2 times 5, because I know that's an easy one. That's 10. And then 9 times 10, just 9. Let's put a 0 behind it. 90. Okay. So let's do a T-chart and reduce what we have. We have 6 and 90. We know 1 times 6 and 2 times 3. All right. 1 times 90, 2 times 45, 3 times 30, 4 won't go into it. 5 times 18, 6 times 15, 7, no, 8, no, 9 times 10. So what's the biggest number over here on this side? I see a 6. We have a 6 over here. Yeah, right there. Okay, so this biggest number here and this number, they'll both go into it. 6 goes into 6 one time. 6 goes into 90 15 times. So 1/15. All right, well, let's try to reduce beforehand. See a 2 and a 2. Those just cancel out and become 1s. Thank you, Ginger. 1, well, no, 1 won't reduce because it's already a 1. We can't reduce 3/5 because it's the top of itself. What about 3 and a 9? We've done this a couple times, haven't we? How many times does 3 go into 9? 3 goes into 3 once, and it goes into 9 3 times. So we have 1 times 1. 1. Times 1 again. Still 1. 1 times 3 is 3. Times 5. 10. There you go. 15. Is 1/15 equal to 1/15? You bet it is. So again, you guys are doing these 4 problems right here. You're telling me if you got the same answer. That's not too severe for you. And you guys are doing the next page. I'm going to start you on the next page. You guys are going to finish the next page. But when you see what's going on with this, you'll be like, duh. Easy peasy. Reciprocals. When we get down to the bottom, the lower part of this is going to make a little more sense to what I'm talking about. So with reciprocals, I remember reciprocal, refliplical. So it's the same number, the same fraction, but flipped upside down. 2/3 times 3 halves. There's the 2, there's the 2, there's a 3, there's a 3. It's just flipped upside down. That is a reciprocal. 4/5 and 5/4. Top to bottom, top to bottom. They match up, right? This one just flipped upside down. Flip it, flip it. Reciprocal, refliplical. When you multiply reciprocal, you come up with 1. Good girl. Sorry, my dog. Multiply and simplify? Fine. We'll multiply and simplify. What's 4 times 5? 5, 10, 15, 20. What's 5 times 4? 5, 10, 15, 20. Same thing, right? Right. Any number over itself equals 1. That's a reciprocal. Look over here. 3/5 and 5/3. On this side, we're going to simplify and then multiply. 3 and 3, same number, right? Cancels out, becomes 1. 5 and 5, same number, right? Cancels out, becomes 1. What's 1 times 1? 1. What's 1 times 1? 1. 1 over 1, 1/1. Any number over itself is 1. Boom. Y'all got this. Okay. Now, some of these aren't true reciprocals. So some of them aren't going to be so easy. 2/3 times 3/4. 2/3 times 3 halves would be reciprocal. Times 3/4, not quite. But the 3 and the 3, those will still cancel out, won't they? Yeah. And 2, well, 2 and 2 would cancel out, but 2 goes into 4, doesn't it? Yeah, how many times? 2 times what is 2? Yeah, 2 times 2. So 2 goes into itself 1 time, it cancels out. And then 2 goes into 4 2 times. So 1 times 1 is 1. 1 times 2 is 2. Oh. Sorry, guys, I did that backwards. I was supposed to multiply first and then simplify. 2 times 3 is 6. 3 times 4 is 12. And like we did on the other page, the greatest common factor of 6 and 12 is 6. It still reduces down to 1/2. We're good. Here's where we simplify and then multiply. Get force a habit. I get used to doing that. Well, the 1 is as low as it goes, so that and the 5 can't reduce. What about 3 and 3? They're the same number, right? So they cancel out. 1. 1 times 1 is 1. 5 times 1 is 5. Is there anything else we need to do to that? Nah, we're good. This right here is the only other one that's not a reciprocal. I want you to multiply it and then simplify it. Over here, you're going to simplify these first and then multiply them. So really, I'm leaving you with 1, 2, 3, 4 problems up top. Not too serious, guys. Y'all could do this. Then we're going to find the reciprocals of these fractions, right? Oh, sorry, up here there's more information. My bad. We're going to draw a loop around each pair of fractions whose product is 1. Like that one. Like that one. You may see, I don't know, 3 more of them while you're doing your next 4 problems there. Two fractions whose product equals 1 are called reciprocals. 4/3 and 3/4 are reciprocals because 4/3 times 3/4 equals 1. It's kind of what we just talked about a few minutes ago, right? 4/3 is a reciprocal of 3/4. It's just flipped upside down. 3/4 is the reciprocal of 4/3. Same fraction, same numbers. Just one's facing this way and one's facing this way. It's okay. So if you multiply reciprocals and you get 1, the reciprocal, flipped upside down version of the same fraction of 3/4 is 4/3, right? Because you're flipping it upside down. When you multiply them, you get 1. 5/2. If I find the reciprocal, that means I'm just flipping this fraction upside down. 2/5 equals 1. 1/9. Well, if I flip that upside down, I get 9/1. We could also call it straight up 9, and that's okay. Because any fraction over 1 is just that top number. So if we look down here, 5. What's the reciprocal of 5? 5's not a fraction, is it? It kind of is. Because any number over 1 is really a fraction. We can take any number, make it a fraction by putting it over 1. So now we can flip this over and get the reciprocal, right? The reciprocal of 5/1, flip it upside down, 1/5. Oh, snap! Does that work? It works. Guys, I trust you to do the rest of this page. So you've got 7 problems down here, 4 problems up here, right? And then there's 3 problems on this page? Well, 4 problems on this page, but they're kind of the same problem, right? You guys got this. Knock it out of the park. If you have any questions, Mrs. Jacobs would be more than happy to help you, and she's super capable. She's a great lady. Listen to her. And if you give her a hard time, I will be so upset. But I know with this class, I don't have to worry about that. All right? You guys are a good set of fellers. I appreciate you. Ginger, do you mind? Sorry. All right. So I'll see you guys when I'm back in class. Should be on Tuesday tomorrow. Till then, have a great day.